started. Started on that warm-up.
We're actually live today?
We're live. We weren't able to be live yesterday because YouTube wasn't working for some reason. But we are live today. Warm-up is on the board, like I said.
I made this.
Have fun with it, huh?
I made this.
Made what?
Look at the source.
Brian Anderson. Yeah, that's you.
That's my middle name.
Oh, no way.
Yeah, right.
Wow, what a coincidence.
Me and Alex have the same middle name. Do you know that?
You know about it.
Wow. Brian?
No, it's not. It is too, Brian. It's James. I just didn't sign my first name.
Got it. Get going on this. It's a great warm-up. We'll do song of the day in a second. I'll give you plenty of time. Work together. How would you go about solving a problem like this? And yeah, you can solve a problem like Maria by just randomly plugging in numbers, and that's fine. You can do that. But what do you notice about the solutions, right? Try to find a pattern. Try to learn something, okay? Figure out maybe where certain numbers cannot go. This is a really good warm-up. It's a stupid question, but it can be really good. We're going to play a song today in a second, but get going. If you're not doing this stuff, you're missing out. So shut up and do it, and then work together and talk.
That's in the same album as...
It's Coloring Book.
What's a good album?
Yeah, that's Pete Chance, huh? Today's the first all day.
This is my favorite song. Wait, you gotta finish the lyrics, right? Where's your stapler, Mr. Ryan?
Where's my stapler? I
That
don't know.
fixed yesterday.
Not really sure. Let me put this. Does it really? Complimentary is 90. Supplementary is 180. Right? I don't understand why that makes more sense, but okay. Well, by definition, we know what complementary and supplementary means, right? And if not, we know now. Remember, you're only allowed to use the digits 0 through 9 once. And again, you should notice something about that. Zero through 9, only once. That is the deal. Should have got that notey. I just got one.
I didn't get one. Exactly.
All right, if you like that better, here it is. Nope, that's not it. Another great album. Song today is by Chance the Rapper, Chicago native. Song is Same Drugs.
This is what best album.
It is probably Pete Chance, which is sad. I'm hoping that he comes out with something better. Latest album, not
It
a
was not
banger.
very good.
Not a banger. It has.
This is a big delay. Oh my.
Yeah, it is. Sorry.
Hang on, let's check the
Sometimes
notes.
it do be like that.
Wait a second, what did I get?
Same drugs. 0 through 9.
This was one of the
We don't do the same drugs no more. We don't do the same drugs no more. Cause she don't do the same drugs no more. We don't do the same drugs no more. When did you change? When do you age? I thought you never grow up. I thought you never. Window closed. Wendy got old. I was too late. A shadow of what I once was. Cause we don't do the same drugs no more. We don't do the same drugs no more. the same way no more. We don't do the same drugs, do the same drugs no more. Where did you go? Why would you stay? You must have lost your marbles. You always were so forgetful. In a hurry, don't wait up. I was too late, a shadow of what I once was. 'Cause we don't do what we say we're gonna. You were always perfect, and I was only practice. Don't you miss the days? Stranger, don't you miss the days? Don't you miss the danger? We don't do the same drugs no more. We don't do the same drugs. Do the same drugs no more. We don't do the same drugs no more. We don't do the same do the same drugs no more. We don't do the same drugs. Don't forget the happy thoughts. All you need is happy thoughts. The past tense past bedtime. Way back then when everything we read was real and everything we said rhymed. Wide-eyed kids being kids. Why did you stop? What did you do to your hair? Where did you go to end up right back here? When did you start to forget how to fly? Don't you call out, don't you please. Stay in the line, stay in the line. Down the line.
Do the same drugs no more. We don't do the same drugs. The same we
don't you call out, don't you please.
We don't do the same drugs.
Down the line.
Same drugs, Chance the Rapper from his 2016 album Carl's Corn Book. Straight up bangers all the way through. Featuring a lot of great artists like Lil Wayne, Kanye West. 2 Chainz makes an appearance at some point. Even your boy Justin Bieber is on one of the tracks. It doesn't suck. What's up? Here's Pac, the final track. Good stuff. All right, so talk to me. You got answers? Got solutions? All right, Zayden, you say you got one. Let's go.
For the first one, it's 38 plus 52.
All right, so he's saying 38 and 52. Let's check that to see if it makes 90. Well, we got 3 and 5, which makes 8. 8 and 2, which makes 10. So we've got 80 plus 10, which is indeed 90. What else do you get?
76 plus 104.
76, 104. And when we do this, we have 70 and 100. That's 170. 6 and 4 is 10. That's 180. Let's check the numbers. He used numbers 1, 2, 3, 4, 5, 6, 7, and 8. Did not use a 9. Makes sense because we only have 8 slots. We've got 9 slots
You can't use
and 10 numbers. Can't use the same number twice. 0 through 9 only once. So checks out. We have a solution. What you got, Mal?
79 plus 101.
79 and 101. Somebody break it to him.
Oh, he's won twice.
Got him.
102 and 78.
I like the effort. That's going to get us 180. He's fighting. Now what? What about the 90?
I didn't think about that.
Somebody help him out.
I'm going right.
Is there a possible way to get a solution here? We've used 0, 1, and 2. We haven't used 3, 4, 5, 6, or 9. 36 and 54.
Appreciate it, Xavier.
Checks out.
What's the smile for?
You do not know what is yet to come. All right. Any others?
Oh, we can't use zeros.
What? What do you mean we can't use zeros? There's 0 right there.
1 through 9.
0 through 9. Directions are hard. Zayden.
You can create a bunch more by swapping out the digit in the ones place with the digit in the ones place in the same order.
Check this out. It's brilliant. What if we switch the 8 and the 2? Still valid, right? Why is that? Why?
Because 5 and 3 will always equal 8, and then it doesn't matter what your second two numbers are if they equal 10.
So the second two numbers, here and here, always have to equal 10. Why is that? Because this guy ends in a 0. So same thing here. And here. And here. We're learning something. So Zayden's saying switch them and they're still add up to 10. You're still fine. Any other solutions? Any other comments? Anything else you notice?
Questions, comments, concerns?
Zayden's got more. What?
I noticed that the ones place digit for any of the numbers cannot be 0 or 5.
Okay, so why can't someone other than Zayden? Why can't the ones place be a 0? Let's talk about that first. Yeah.
Well, if it's a 0, you can't add anything else to be a 0, like anything 0.
Okay, so we know what about these two numbers? They have to add up to what? They have to add up to 10. So if one of them is 0, what do we have to add to that to make it 10? 10. Can you put a 10 in a single column? No, you can't.
You would use 0.
You would use 0 twice. Exactly. So we know that none of these can be zeros. All right. All right. This is a stupid question. Like, who cares, right? Like, what numbers add up to 90? What other numbers add up to 180? It's not a good question, but all the other things you're finding out about this is really cool. I picked this warm-up not knowing how cool it was, and first hour just blew my mind. And you guys are doing the same thing. We recorded it, luckily. You can go back and watch it. Yeah, Jess.
The last digit can't be 9.
Why can't the last digit be 9? So the digit here or here, is that what you're talking about? Okay. Why can't those be 9s?
The first digit in the 3-digit number has to be 1. Those will go for 1.
Okay, hold on. One at a time. So this has to be a 1, you're saying. That's your conjecture? Okay, that has to be a 1. Interesting. Let's go back to the 9 thing. These guys all what has to be a 9? What were you saying?
The end numbers have to be, or can't be 9.
They can't be 9, she says. Now, why can't they be 9s?
Because then you have to add 1 to it and we already used the 1.
Oh, I get what you're saying. So she's saying, I've got two things. She says, these have to be 1s, which therefore means none of these can be 9s. Because if they are, you need a 9 and a 1 here, and you use 1 twice, right? Now, can anybody think of a counterexample? Because right now, that's just a conjecture. Is there a way to prove that wrong, that you don't have to use a 1 here or here? Zayden.
Maybe we could find a possible way of using 0 in that place and then using the other numbers to add it up.
Okay, so why did you say originally that there has to be a 1 here? Why did you come to that conclusion? I know why you did. Do you want me to tell everybody?
Sure.
Okay, so check it out. She's saying this has to be 180. And she's saying, well, if that's 180, there has to be a 1 here, right? Now, she regrets this choice because she's realizing we can carry digits, right? So we don't need a 1 there. We could have a 0, and I'll show you how we could have a possible solution. So if we have 0, something, 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 that's the 180. I'm flipping these, sorry. And then we have these two. Okay? Give me a solution. With a 0 here. Yeah, go ahead.
8694.
So 8694. Okay. First of all, does it obey our rule that these guys add up to 10? Yep, cool. So we have 10 plus 170. That's 180. Okay, so now we've got this. Is there a possible way to get numbers down here and make it all work? Well, we know that these guys have to add up to 10, right? So what digits do we have left? 1, 2, 3, we already used 4, 5, we already used 6, 7. What digits can go here and here that'll add up to 10? 7 and 3? Okay, it doesn't matter where we put them, right? Just put them here and here. All right, we can flop them. We figured that out earlier. So 7 and 3 are gone. That adds up to 10. What does that tell you about these two numbers? They have to add up to what? 80 or 8, depending on how you look at it, right? If you're looking at it as like those are tens columns, right, it adds up to 80, right? Like a 3 and a 5 would be like a 50 and a 30, right? Or you can say they just add up to 8. So what two numbers add up to 8? Do we have two numbers down here that add up to 8? So it's impossible. Is there another combination of numbers that we could put here that add up to 10 out of these guys? So it's impossible. Oh man, we didn't get an answer. It's all about the answer, right? No, you done learned. What do we learn? We can test to see if it's impossible very easily. These have to add up to 10. We only have one option. Yep, doesn't work. That's learning. You smell what I'm stepping in? Okay, so what do we know? Let's write this down. So we know, given this information. All right, tell me something we know. What have we learned? All right, so ones columns, that's an NS, sum to 10. What else do we know? What about zeros? Go ahead, yeah.
Has to be in a 3-digit number. Like,
You say the 0 has to be somewhere in here? Maybe. We don't know yet. We haven't proven that necessarily. That's a maybe. I don't want to write that down unless it's for sure. It really could be, but I don't want to write it down yet because we just found one example where it didn't work. Doesn't mean that it doesn't work in any examples. Could have just picked bad numbers, right? What else do we know? What else have we learned? Yeah, go ahead.
The 0 can't be in the ones
0 can't be in the ones
place.
place. I mean, it's kind of saying the same thing, right? They have to add to 10. If you have a 0 there, there's no way to make it add to 10, but we'll write it down anyway. 0 can't be ones column. We learn anything else? What about these guys? Well, let's stop. How about these guys? These two. What do they have to add to? They have to add to 8, right? Because if that guy's a 10, that has to add up to 80, right? So these have to be 8. Now what about these guys? What do they need to add to? If that's a 10, what do they need to add to?
8.
Not 18, because that gets us 190. If these guys add to 10, these guys need to add to 17. Okay, so we know that 10's column in the 2 digits, right? 2D10 column need to sum to 8. So, in other words, these two guys have to add up to 8. Because that'll get us 80 and then the 10 gets us 90, right? These guys all together, these three numbers right here, have to add to 17. That way we get 170 and then 10 gets us 180, right? So let's write that. The 3D tens and hundreds column must sum to 17.
Pause for a second.
I can, for station identification. Welcome to Mr. Mack's class. This is geometry. Today is the 1st of October. We're talking about supplementary and complementary angles.
Not right now, though.
Yeah, we are.
Oh, yeah.
Oh, yeah.
Yeah.
All right.
I was thinking of proofs because that's
Yeah. I know what you're thinking.
You did
Shout out to
it.
Jared
You-
Sense.
you didn't
Jared
get it.
Smells.
Hold on 1 second.
That's right. That's where that comes from, actually. I had a kid named Jared Sense, and I called him Jared Smells. It was his last name, Sense, right? And so I smelled what he was stepping in, because he would always go, oh, that's not what I meant, but you know what I mean. It's like, oh, I smell what you're stepping in. No! Wait for it. It's like a minute behind. There it is. Okay, cool. All right. So, using this information, let's see if we can find another solution, right? So we know that these rules have to be true thus far. Can we make a solution with a 0 here? That's 90. That's 180. We were testing to see if we could have a 0 here, right? Well, what do we know about these spots? We just said it. They have to add up to what? 17! So give me 2 numbers to put here that add up to 17. Danny.
8, 9.
8 and 9. Where do you want to put them? 8 here or 9 there?
Let's put 9 on the right. 8 on the left.
Okay. So they add to 17. What do we need to know about these numbers? They need to add to what? These guys right here have to sum to what? 10. Give me 2 numbers that add to 10 that aren't 8, 9, or 0. Catherine, give me 2 numbers that add to 10. 4 and 6. Where do you want to put them? Here or here? Doesn't matter, right? We proved that earlier. That's another thing we need to write down. Can swap same columns. So you said 4 and 6? Okay. Doesn't matter where we put them. 96, 84, that's at 180? Oh, yeah. Oh, yeah. Shout out to Mr. Lavelle. All right. So we've used, these are the numbers we have left. 1, 2, 3, 5, 7. It's the same dumb crap, just with these guys switched. Want to try again? Maybe you guys are just really bad. That's very possible. Because they're freaking morons. All right. You know why I call you morons?
Because we're learning more on this topic.
Because when I don't call you a moron, then you know I'm not joking.
What?
And I think that's important. So when I don't call you a moron and I say, hey, you've done a good job, you know I'm not joking. And I think that trust is important.
Oh, okay. So we're supposed to funnel, but not gonna
Right?
save it on your, is that what you mean?
Right? I think that's important. What do we know about these sets of numbers? Add up to 17. Give me 2 numbers that add up to 17 where this is a 0. Well, we did 9 and 8. 9 and 8 is our favorite. Can't be a 9 or an 8.
Is there, there's only that.
Wait, hold on. What about 7 and 10? What about 6 and 11? We can't. What do we learn? She's right.
I just said I thought.
0 can't go here. 0 can't be Hector in hundreds. All right, we've got some theorems here. Okay, so impossible. Right? So we know when we're doing this, these 2 guys, right? These 2 guys. We know that these guys add up to 10. We know these guys add up to 8. We know these guys add up to 17. We know these guys add up to 10. We know zeros can't go here, 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 or here, and they can't go there. That's good because now we have less things to test, right? We can come up with solutions much faster. We're learning something here. All right, so what else do we want to try? I've got an idea. What if we figure this one out first? And then we divide everything by 2. Will that pop out right numbers? Give me a solution that works down here. Give me 2 numbers that add up to 10. What's up?
You said 7 plus 12 equals 19.
She's right. What is she saying? Why did you say that?
Because I thought it was 17 earlier, but he said it was 18, but then I thought it was 19.
Oh, the numbers here? Okay, I get what you're saying. Mhm. Let's go back a second. We said that these guys have to add up to 10, and these guys have to add up to 17. Right? Okay. You haven't noticed it yet. Okay. So give me 2 numbers that add up to 10. 7 and 3. Doesn't matter where I put them, right? Okay, 7 and 3. We've got lots of numbers left over. Give me 3 numbers that add up to 17. So pick 2 and then give me the number that's left over, right? We already did 9 and 8. Remember, that requires a 0 for the third number, and we can't do that. Say it again?
1, 2, and 6.
1, 2, and 6. So 1, 2, 6. Why won't that work? Why can't I do a 1, 2, and a 6?
It's a 6, 1, and 2.
Okay, why can't I do a 1, 2, 6?
Right.
Why can't I do a 1, 2, and a 6? In that order. 1, 2,
1
and a 6.
Yeah.
It's already too high. So what do we know about this column? So the hundreds column has to be 1. It can't be 0, right? And it can't be 2 because now we're too big. So it has to be 1. Sorry, hundreds column must be 1. This is a stupid problem, right? Give me numbers that add up to 90. Give me numbers that add up to 180. Only use 0 through 9 once. But good Lord, this is a good problem. All right, so that has to be a 1. Always. So now give me 2 numbers when you add 1 to them, get 17. In other words, these 2 numbers had to add up to what? 16, right? These 2 numbers have to add up to 16 because that one's going to make them 17, right? So before we said these numbers have to add up to 17, right? But now we know that always has to be a 1. So there's an easier way to write this rule. These numbers must add up to 16. Right? To get all together, they should be 17. The 2 there should be 16. So let's change that. 3d10s must add up to 16. Okay, give me 2 numbers that add up to 16 that we have left over. Come on, you can do this. Okay, so here are the numbers we don't have. 2, 4, 6, 5, 8, and 9. And 0. Right? We've used 1, 3, and 7. Okay. Come on, somebody else. You can do this. Give me 2 numbers that we have left over that add up to 16. Decker. 2 and 5 get us 7. We need numbers that add up to 16.
We don't have 18, 9, and 7.
That's 14.
9, 7, 16.
No, I'll talk to myself.
Yeah,
8, 16.
And 9 and 8 is too big, so
because that's 10, not 1.
we're not able to do it.
Just got it. These numbers don't have to add up to 16. Wake up! What do they need to add up to? They need to add up to 7.
2 and 5 is correct. Valid.
Because we do 2 and 5 here, right? That works.
No, I would have paid for that.
We get 10 plus 70 plus 100. And 10 plus 70 plus 100 is 180. So 2 and 5. All done. Interchangeable, of course. All right. Okay, so now, is there a possible solution up here? How did we figure that out last time if we was able to actually solve it? How did we figure that out? Well, these guys had to add up to 10, right? Do we have a possibility of adding up to 10? What two numbers do we have that actually add up to 10 that are left over? 4 and 6. So 4 and 6, after we do this, are locked in. Now, what do these numbers have to add up to? 8. Do we have any numbers that add up to 8? 8 and 0. So 0 can go in the tens column. We win. You don't have to figure out all these numbers at once. You just have to figure out a few. In fact, you only have to figure out 4. Because 1's given to you. Literally. The other 2 are free. Let's see if we can make another solution without trying too hard. Let's try again. Oh, relax. All right, using this knowledge. Because now we have knowledge. Before we just had guessing. Yes, sir?
I think I solved another one with 0 and 2 in the front.
0 and 2 in the front. Where are we talking?
On 180, 0, 2.
Right here?
Yeah.
Okay, so check it out. Using that, we're going to guess what number he has. Maybe we can figure it out just from here. Okay, check it out. Here's what we're going to do. What do we know about these two? They have to add up to what? So what does this have to be? 8. It's like Sudoku, right? Or whatever it is. This thing. Sudoku. Seppuku. Right? This has to be a 7. And that has to be a 1. We know that always, right? That works. Now, what numbers are left over? Well, we have 1, 2, and 0 already done, so we have 3, 4, 5, 6, and 9 left over. What numbers have to go here? Numbers that add up to 10. What numbers do we have that add up to 10? 4 and 6. Any others? No. So 4 and 6. Doesn't matter where we put them, right? Again, all of the digits, 1s are always interchangeable, 10s are always interchangeable, right? That gets us permutations, which for my purposes, I'm going to say are all the same solution, right? Why bother writing them all out? Gone. What has to go here? Do we have numbers that have to 8? Guaranteed solution every time. Is that what you had? And is this your card? Right? Mathematician. It's in the hat. It's in the hat. That's dope, right?
Crazy. Is that how you make like the warm-ups?
That's how you should make the warm-ups. Is this a hard question to come up with? Numbers that add up to 90, numbers that add up to 180. No, and it's a boring question. But this is way more interesting. You want to know what's really going to blow your mind? Illuminati confirmed. What do you notice about 3, 4, 5, and 6?
They're all ordered.
They are. Coincidence. I could have switched the order, though. Is there a way to make these all in a row from ascending? No, okay. Now we'd have 0, 1 here. We'd have to have a 2 there. Yeah, 1 has to be there. Doesn't make sense, right? It'll always be not, because a 1 has to be there. We're going to have 2 numbers before it. It's not going to work, right? Here's what's going to blow your mind. What's 3 plus 4? What's 5 plus 6? What do they add to? What's 1 and 7? Plus 8? Plus 2? 18. What's 8 and 6?
14.
Plus 4?
18.
What's 2 and 7? What's 1, 3, and 5? 18.
I'll loop it down.
What's 3 and 8? 5 and 2 is 7. That's 18. 7 and 6 is 13. Plus 5 is 18. 7 and 8 is 15. Plus 3 is 18. 3 and 6 is 9. 5 and 4 is 9. 18. 8 and 6 is 14. 9 and 4 is... Wait, what? Oh, yeah, that one didn't work. You know how I knew it didn't work instantly? Because those digits are already too big. They're over 18. Why? Hi. Why do all the digits in the row have to add to 18? Why? Why? Why does it have to 18? Illuminati confirmed?
I think you get 3 times this. Crazy math.
Why do they have to add to 18? What?
Zayden knows.
180 is 18, and he's right.
Zayden knows.
You're right.
18, 90 is 9 is 18.
Yes, you're correct. Zayden, what do you have to say?
Conjecture.
90 and 180, their common factor is 18.
Oh my god.
Oh.
Does that matter? I mean, maybe he's right. First of all, let's see if he's right. Does it matter, though? Like, who cares? So here's 90. Here's 180. Let's list their factorization. So how do we do that? Well, what we're going to do is we're going to make the jail thing, right? Here's 90. It's in jail. We're going to break it apart. This isn't really jail. It's more square roots that are in jail. Give me the prime factorizations. We've got 3 and what? 3 and 30. 30, whoops, sorry. Don't circle 30. 30 breaks down into what? 3 and 10. Very good. I'm glad everybody agreed. And 10 breaks down into 2 and 5. Excellent. So we have 3, 3, 2, and 5. So another way to write that is 2 times 3 squared times 5. You dig? 3 times 3 times 2 times 5. 2 times 3 times 3 times 5. Why do I not need to break down 180 now? How can I get his factors for free? Just multiply by 2, right? So how many 2's do I have? 2. All right, so you were saying, what were you saying, Zayden?
I was saying that
Listen up!
18 is a factor of both 90 and 18.
Okay, so 18. 2 and 9, right? And 9 breaks down into 2 3s, so it's 2 and 3 squared. With the leftover 2. Well, don't they have other common factors? 10. I'm not convinced. What?
Would 18 made their highest common factor?
Listen up! He says 18, highest common factor. Well, no. Because 9 times 5 is 45. In fact, their highest common factor is 90. Everything except one of the 2's. Good conjecture. Why does 18 occur here every single time? Illuminati?
Confirmed.
What do these two have to add up to? What do these have to add up to?
8.
What do these have to add up to?
10.
What do these have to add up to?
7.
17. So you're telling me these and this right here have to add up to 10, right? And the 3 and the 5, those ones right there have to add up to 8. And you're telling me here, these guys, right, have to add up to 10. And these guys here, oh no, have to add up to 17? What do you notice? So if you add them together, you get 18 here and you get 27 there. That's true. What else do you notice? I used to do this with license plates. Give me some numbers. Why is that funny? I don't understand why that's funny. 5, 3, 2.
Some cars have like 4 by 4 and like stuff like that.
Yeah,
You gotta put equal sign 16.
I'm dumbfounded. All right, so let's add all these up. What's 5 and 3?
4x8.
Plus 2 is? This is 10. What's 1 and 0? 1. What's 6 and 1? Plus 7 is 14. 1 and 4 makes 5. What's 1 and 5? 6. So I'm adding all the digits, right? Can you get a number that's different than 6? I did 5 and 3 first, and then added 2 and got 10. Is there another way to get another number than 10? No, because adding is commutative. You can do it in any order you want. Same thing here. I could have done 6 and 1 first and got 7, or I could have done 6 and 7 and got 13. 13 is 4. 14 plus 1 is 5. Every number has a magic number. I don't know what to call it. Maybe we'll call them Mach numbers, right? That number, 532,617 is 6. Always. No matter how you add them. It'll always get down to 6. Calm down. What's the Mach number here? 9. What's the Mach number here? 9. What does that mean? Does it matter? Am I pulling a Zayden? I want you to figure out why they always add up to 18. Do that. Self-development. Figure it out. Figure it out. Yeah, but is that a coincidence or is it not? Because Zayden earlier was like, oh, look, 18's a factor of both. Well, yeah, lots of factors. But anyway. Your homework.
I got it.
Thank you.
Wait.
Write it down. Take a picture. I don't care. That's your homework. You're given the stuff that matches the given, right? And then the proof is in blue. You got 2 problems.
There we go.
Do the same.
That song though, like
Yeah.
it says the Mac Dad. That's you.
That's not what I was talking about, but okay.
Mac Dad.
Stupid problem. Interesting things about it. Make me warm-ups. You know you get self-development for that, right? It doesn't have to be difficult, okay? We are heading into October. It's October 1st. Make me warm-ups. Do it. It's fun. And they don't have to be complex. I can make anything look
I'm
cool.
gonna come to urine today. Actually, I can't.
You're going to be in the urine today?
What?
Sit down. Do you listen? Do you hear yourself sometimes?
I'm coming to your room.
Ugh. I can't unhear it. All right.
You can't hear it.
Your homeroom's lit, so it's fine.
It is lit. That's what I try. Zayden, go back there and grab something out of the green bin back by the books. Tape it to the wall. You may cut it if you so desire. Don't tape over anything that's cool, but add to the mural.
What am I doing?
You're adding to the mural. Shut up and do it. That's right. Conformity. What? Yeah, just tape it to the wall, wherever you want. Don't cover up anything cool, though. Make sure it adds to the aesthetic. Yes! Good Lord. That was like 10 minutes ago. Send help. All right. Do you have this? You got it?
Yes.
That's your job. Let's talk about what this means. J, E, and T, they're points. They're collinear. You should be able to draw me a diagram.
This will be one day in Mr. Max room.
I know. JE equals ET is given to you. ET phone home. I want you to prove that 2 times JE, so double JE equals JT. Think about what that means. Number 2, they want you to prove that CA is equal to R, or I'm sorry, they give you CA as RD. So you should know this. Prove that CR is congruent to AD. I'm going to do that again. CR, AD. Ah, Katie. Brilliant. Chef's kiss. You know what S stands for? Yeah, you don't need it. It doesn't do anything for this proof, does it? That's what I need you to do. Make me warm-ups. to do that stuff. That's what it was. But you have a warm-up sheet, so good for you. Yes, but we ran out the other day, so I thought you didn't have them, and I thought you'd need extra room to get stuff done, right? Everybody's always complaining about there's not enough room.
What is this?